Alright guys, here is our next video on trig identities. Please look for a homework help video a little bit later. It'll go through any of the ones that we had major questions on the homework yesterday. So, in this lesson we're looking at the next two ideas, identity idea number 4 and number 5. They both have to do with factoring. So I'm going to walk you through this. But I am also going to have you guys do a class kick after this so you can practice the skills that I'm teaching you here. So the first idea, identity idea number 4, is to see if there's something that they have in common that you can factor out, a GCF, a greatest common factor. So if you look at this first example, since both of these have a cosine, we can actually take that out. Just be careful, when you take it out of the first one, there's still going to be a 1 left. So it's going to be cosine factored out, 1 plus the tangent squared is left. And our goal is to get secant x out of this. So if you look at this now, that inside part, 1 plus tangent squared x, is going to be on your plate. It's actually right over here. That's actually equal to secant squared x. So I can rewrite that. It's going to be cosine x times secant squared x instead. And our goal is to get that to equal secant x. And now we have to go back to the other parts of our plate, and we can actually change out secant x, secant squared x. Secant is the reciprocal of cosine, so I can flip that over, and that's going to be times 1 over cosine x, cosine squared x. And what happens here is when one of them is squared, when you go to cancel, one of these canceled with one of those, so it actually still leaves 1 on the bottom. So we're going to get, I ran out of room, 1 over cosine x equal to secant x, and then I can take 1 over cosine x and flip it back over and make it secant x is equal to secant x. Not the only way to do that. You could have actually also changed the cosine x, this pink one back here at the beginning, you could have changed that to 1 over secant x and canceled. It actually would have been faster, but since we have that rule of changing everything to sines and cosines, I went that direction. But there's more than one right way to get this answer. Alright, so that's one of the methods. The other method we're looking at today is to factor. If you're looking at something and you can factor it, we can use any of the types of factoring we've used. Difference of squares, perfect square trinomials, quadratic model, things like that. So my suggestion for you is to do a little side work to turn this into something that looks a little bit easier by using u. So over here on the side, I'm going to say that u is going to equal sine x in this problem. And I'm going to rewrite that left side. It's going to be u squared minus 1 over u minus 1. This is just going to help you to set up the factoring part, then we're going to write it in the identity. So if I wanted to factor that, I hope you realize that this top part is a difference of 2 squares, and it's going to factor to u minus 1 times u plus 1 over u minus 1. So I can now rewrite that in my problem. I can write that with the sine x in for u instead. It's going to be sine x minus 1 times sine x plus 1 all over sine x minus 1. So then, if we look at what cancels, these cancel, and I'm left with sine x plus 1, which is what I wanted it to equal. That's what the other side said. So I'm done. Check. Let's look at another one. Alright, again for this one, I would do that side work of let's figure out what we're going to call u. Since this one has 3 parts, it's a little bit easier to figure out what to call u. It's going to be that little middle part. U is going to equal tangent x, and then we're going to end up with the top being u squared plus 5u plus 6. And we can work on factoring that. Now that they're u's, it's a lot easier to look at it. Factors of 6 that add to 5 is 3 and 2, so it's u plus 3 times u plus 2. So it's going to turn into, now we got to put the tangent x back in, tangent x plus 3 times tangent x plus 2 over, the bottom was tangent x plus 3. And again, we have something that cancels, so it's cancel. we get tangent x plus 2, which is what we wanted it to equal, equals tangent x plus 2. Check, got another one done. So it's all about looking for what you're going to call u and working with that. This next example, example number 3. Again, this one's a little different because it's to the 4th power, and there should be, it got deleted, there should be an x in there. So we'll pretend that x was there. This time we're going to call u cosine squared x. So if I want to factor this, the cosine to the 4th is really going to turn into u squared minus 2u plus 1. So now I'm looking for factors of 1 that add to negative 2, which is negative 1 and negative 1. So it changes to u minus 1 times u minus 1. It's actually a perfect square trinomial, because the first term is a perfect square, it's just u squared, and the last term is 1, which is 1 squared. It's a perfect square trinomial. So now when I go to rewrite this in the problem, I have to make sure that I'm plugging cosine squared back in for u. So it's going to be cosine squared x minus 1 times cosine squared x plus, no, minus 1 again, sorry, minus 1 over cosine squared x minus 1. And one of those cancels, but one of those is going to stay behind. Cosine squared x minus 1 stays behind. And our goal is to get that to equal to negative sine squared x. So now we have to look at our plate and figure out what I can do here, because I have cosine squared and I'm trying to get to sine squared. So if I look, I'm probably most likely going to be using this first one that talks about sine squared and cosine squared equal to 1. And you have to decide what you want to plug in. We could solve that for cosine squared and plug that into the problem. You could plug in for 1. We know that 1 is equal to this part, so you could plug that in for 1. I think that's the direction I'm going to take here. But you could also do my trick where you solve for cosine squared, and cosine squared is 1 minus sine squared. And then you could plug that in for cosine squared. But just to make it maybe easier, I'm not sure, I'm going to plug in what we know 1 equals. So 1, instead of 1, I can write that whole thing is equal to sine squared plus cosine squared. Notice my use of parentheses. That's going to be important. And again, our goal is to get it to be negative sine squared x. You have to distribute that negative to both of them. So it's negative sine squared x minus cosine squared x equals negative sine squared x. And then the cosine squareds cancel. And I get negative sine squared x equal to negative sine squared x. Check. Alright, we have, I think, one more example. So this last example, when we look at this, this is actually a difference of 2 squares, even though it's to the 4th power. So the way I would suggest that you do this, and this is kind of the harder one to explain, is that to figure out what u is going to be, we'll just call it cotangent theta. That's what we'll call it. So u is going to be the cotangent theta, so this is really 1 minus u to the 4th. And then we have to factor that, so that they're both perfect squares, so we're going to take the square root of both of them, so it's going to be 1 minus u squared times 1 plus u squared. And then we can go ahead and plug in the cotangent back and go back to our problem. So this is really just scratch work on the side, but it helps us to factor it. So it's 1 minus cotangent squared theta times 1 plus cotangent squared theta, all over that original bottom 1 minus cotangent squared theta. So then again, the goal would be that something cancels here to make this simpler. It cancels and we have 1 plus cotangent squared theta, and our goal is to get cosecant squared theta. So now we have to refer to our plate here is what do I know about this part with the cotangent squared and the 1. There's something I can do to simplify this, and if I look, it tells me 1 plus cotangent squared is actually cosecant squared. So this turns into cosecant squared theta equal to cosecant squared theta. So that one wasn't too bad. It's just the factoring part. You gotta really use that u to help you to set it up. So I have a class kick that I want you to do. The class kick code is WLWTCA. So if you can log on, try those 2 problems. If you get stuck, raise your hand and say please help, and I'll give you a hint to get you started. So, or if you're halfway through the problem and you're stuck, that'll tell me that you need help. So if you can try and do the class kick by the end of the day, and then the homework will be due on Monday. I'm going to work the homework the same way. I'm actually going to ask you probably by like Sunday at 5 if anybody's worked on it, where the questions are, and I'll make some videos that you can watch at the beginning of class on Monday. Again, I won't be there Monday, and you're getting a worksheet to work on. It's just going to have 6 problems. But I want you to be able to watch those videos first to kind of get an idea of where you might be struggling on some of these and how to fix those before you work on the worksheet. So that's kind of the plan for Monday, but I'll need some feedback from you guys on where you need help. So look for another Google document post. I'll probably include it on this assignment.